All right, 5.7b. Sometimes you're given zeros and asked to write a polynomial function. So if they tell you your zeros, your intersections are 1, 2, 3, we would start off by saying f of x equals x minus 1, x minus 2, x minus 3. Because if I applied the zero product property, that's how I would get back to the 1, the 2, and the 3. But we are asked to write the polynomial. So you need to multiply these all out and figure out what the polynomial is. So pause the video, give it a try, and then we'll have the solution showing. All right, so I multiplied these two first, got x squared minus 3x plus 2, then distributed the x minus 3, and then once we got to this line of terms, we combined our like terms and ended up with this as our final answer. This problem is a little bit deceiving. Remember that complex roots come in pairs, so while they only present 3 values, we know that with complex roots we're going to have a plus or minus value. So we have, x minus 2, x minus 2i, next parenthesis, x plus 2i, then we have x minus 4 minus the square root of 6, and then x minus 4 plus square root 6. Squeeze that right in there. On the next line, I started to regroup or simplify a little bit. So this x minus 4 and this x minus 4, I put those two together instead of combining the 4 with the radical. And then here, if we distribute the x and the x, we end up getting x squared. We get positive 2ix, negative 2ix, so that's going to cancel. So now we're just left with a final term, minus 2i, the quantity squared. So the I squared becomes a negative 1, and we have this negative, and then we also are going to square this 2. So that comes out to be positive 4. So because we had x minus 4, I just squared it. Then we have negative square root 6 and times a positive square root 6, so it becomes a negative square root 36, and the negative square root 36 is just minus 6. Using what we know about special products, we have square the first term, x squared. We square this last term, and that's going to be plus 16. We multiply these two together, we get negative 4x, and we double, so negative 8x, and we bring down the minus 6. Positive 16 and a minus 6 will actually be equal to a 10, so let's switch that so I can save a little bit of space. Next we can say x times x squared, so we end up with x cubed, x and the 4, 4x, negative 2x squared, and minus 8. And we still have our x squared minus 8x plus 10. Next, we distributed every term in the first parenthesis with the second parenthesis, and I got this big long answer, and I apologize, this isn't optimal, but I couldn't fit my last 3 terms on the line. And then the final step is going to be to combine our like terms. This last line is our final polynomial. It says x to the fifth, that's the highest degree. Recall that when we started we had 1, 2, 3 zeros, but we had complex values, and we know they always come in pairs. So that's why we ended up with a polynomial with a degree of 5. I chose this problem because it had square roots, and we were dealing with imaginary numbers. So please remember it's x minus the value, as we had over here at x minus, but because it was complex we also had to do x plus. And the same thing with our radical. It was x minus, and we had a plus, a minus and a plus.